In this final screencast, we work a few selected examples to help you solidify the ideas you've seen in the previous screencasts. Let's start with example 9.14. Complete the table below. The first row has been completed for you as an illustration. So let's start by looking at this first example. So suppose that you have a factor of 1.42 over a 2-year period. The 1.42 corresponds to a growth, in this case, of 42%. So in terms of the percentage change, we're talking about a 42% increase. And that's over a 2-year period. Now suppose we wanted to calculate the growth or decay factor over a 1-unit time period. So in this case, we're talking about a quantity that grows by 42% over a period of 2 years. But we could ask, by what percentage did it grow over 1 year? Recall that if R is the factor over n units of time, then R to the 1 over n will be the factor over 1 unit of time. So in the first row, if we want to calculate the 1-year growth factor, we take our 2-year growth factor and we raise it to the 1/2 power. The half is coming from the 2 years, so the 2 would be like the n here. So taking 1.42 and raising it to the 1/2 power, if we put that into our calculator, we arrive at an approximate value of 1.19, which corresponds to a 19% increase, and that would be the increase per year. So let's try this out in the second row. We have a factor of 0.84 over a period of 3 months. Because this factor is less than 1, we're talking about a decrease. And this factor represents the percentage remaining. So we're talking about 84% remaining, which means we will have lost 16%. So we've got a 16% decrease over these 3 months. Now let's calculate the decay factor over a 1-month period. We take our 0.84 and we raise it to the 1/3 power, because the 0.84 was the factor over 3 months. So to go to 1 month, we raise to the 1/3 power. If we work this out on our calculator, we arrive at an approximate value of 0.944. Now remember, a factor like this represents the percentage remaining, so we're really talking about 94.4% remaining. So after a 1-month period, we have 94.4% remaining, which means we've actually lost 5.6%. So we've experienced a 5.6% decrease, and this would be per month. Now let's look at the third row. The factor is 1.67. Since it's larger than 1, we're talking about a growth, and in this case it's a growth of 67%. So we have a 67% increase over 5 years. If we want to figure out what the factor is over 1 year, we take our 1.67 and we raise it to the 1/5 power. If we work that on our calculator, we get an approximate value of 1.10. This corresponds to a 10% increase. And this would be per year. Finally, if we look at our fourth row, we have a factor of 0.5 that corresponds to 50% remaining, which means we've lost 50%. We've experienced a 50% decrease over a 10-day period. If we want to figure out what the factor is over a 1-day period, we take our 0.5 and we raise it to the 1/10th power. And if we work that out on our calculator, that's approximately 0.933, which translates into 93.3% remaining. Again, the factor is the percentage remaining. So, what have we lost? We've lost about 6.7%. So we've seen a decrease of 6.7%, and this is per day. Okay, let's go ahead and look at example 9.15. For each of the situations below, determine the growth or the decay factor over the specified period of time, and then calculate the corresponding average percentage growth or decay over 1-unit time periods. Note, these quantities do not necessarily grow or decay exponentially. Consequently, they may not grow or decay by exactly the same percent over 1-unit time periods. So the percents that you find will only be averages. Let's look at part A. So in this case, we're talking about a quantity that grows by 45% over a 10-year period. So this would correspond to a growth factor of 1.45 over 10 years. If we wanted to calculate the growth factor over a period of 1 year, we would take the 1.45 and raise it to the 1/10th power. And if we work that out on our calculator, we get approximately 1.038. And this corresponds to a 3.8% growth, and this would be per year. Now this percentage growth would be an average annual percentage growth, because all we know is that this quantity grew by 45% over a 10-year period. This averages out to a 3.8 percentage growth annually. Now let's look at part B. This quantity decays by 21% over a 3-week period. The decay factor in this case represents the percentage remaining. The percentage remaining would be 79%, and if we write this as a decimal, it would be 0.79, and this is over 3 weeks. So if I want to calculate the factor over 1 week, I take the 0.79 and I raise it to the 1/3 power. If I work that out on a calculator, I arrive at a decimal approximation of 0.924, which of course corresponds to 92.4%. That's the percentage remaining. So the decrease, the amount lost, was approximately 7.6%. So we're talking about a 7.6% decrease per week. So in other words, if a quantity decays by 21% over a 3-week period, that corresponds to an average decrease of 7.6% each week. Okay, let's go ahead and look at our final example, 9.16. In the year 1999, global consumption of bottled water was approximately 26 billion gallons. By 2004, consumption reached 41 billion gallons. So in Part A, by what percentage did consumption of bottled water increase during this period? Well, how long a time period are we talking about? From 1999 to 2004, that's a 5-year period. So over 5 years, what was the factor, first of all? Well, the growth factor over this 5-year period is found by taking the final value, which is the 41 billion gallons, and dividing that by the initial value, which was 26 billion gallons. And if we do the division, we arrive at a decimal approximation of 1.58, and that corresponds to a 58% growth during this 5-year period. So now let's look at Part B. What was the average annual percentage growth during this period? So I want to emphasize that in Part B we're talking about an annual percentage growth, whereas in Part A we were talking about a percentage growth over 5 years. So in B, if we want to calculate the average annual percentage growth, we take our 5-year factor, and which was 1.58, and we raise it to the 1/5 power. And if we do this, we arrive at a decimal approximation of 1.096, which corresponds to a 9.6% growth. And this is annual. So this is the annual average during this time period.